Good morning, everyone. In our analog electronic circuits lecture series, today we are going to discuss about diode. Already in a previous session, I have given you the some introduction and fundamentals of diode and the types of diode. Here in this video, we will discuss about the various types of operation and applications of diode. We will see in this video. Come, let's get into the video. So I already told that diode is nothing but it has a two terminals. One is anode and another one is a cathode. That's why it is called as a diode. There is a two terminal. That's why it is called as a diode. Here, the diode is made up of with a P-type material and N-type material. So because of the P-type material and N-type material, so both will be joined together. So that will create some junction between these two. That's a P-type material and the N-type material. So in the P-type, the majority charge carriers are holes, and the N-type, the majority charge carriers are electrons. So because of this formation, that creates some junction between these two. That junction is called a depletion region. So the junction will have a positive and negative ions. That because of that, it will create some electric field, right? So based on the material which we are using, that depletion region potential will be varied. If you are using silicon, the depletion region potential will be what 0.7, and if you're using germanium, that will be 0.3 voltage. So this is the simple PN junction diode construction. And coming to the operation, the diode has three types of biasing operation. One is no biasing, and another one is a forward biasing, and then next one is a reverse biasing. So no biasing is that means that if PN junction diode is not connected to any external supply, it will be called as no biasing. So biasing in the sense giving external supply to the device is called a biasing. So obviously, if there is no supply to the PN junction diode, that is called as a no biasing. And comes to the next one, that is a forward biasing. Forward biasing in here, the positive terminal of the supply will be connected to the P type, and if you are connecting the negative terminal to the N type, means this is called a forward bias. This means that when you're increasing the external supply in the circuit, external voltage in the circuit, what happens? The depletion region between P type and N type will be decreases gradually. When you're increasing the voltage, external voltage, that decreases the depletion region. At some point, that means if the input voltage, if the applying voltage is greater than of the depletion region voltage, at that point, the current conduction will be takes place in the PN junction diode. So this forward bias, obviously that means that it allows the current flow in some after reaching some particular reference voltage. So this is the forward bias of the diode. And next type is diode in reverse bias condition. So in a previous forward bias, we connected the positive terminal to P type and negative terminal to N type. This reverse bias is just the opposite one. Positive will be connected to the N type and negative will be connected to the P type. So because of this thing, the depletion region, instead of decreasing, it is depletion region will be increased when you are increasing the external supply. So here in this reverse bias, there won't be any current flow in this case. So this is the reverse bias condition. You can see here there's a real-time example which is which is shown in the slide. So first image is nothing but a diode in a forward bias function act as a conductor. So forward bias, I already know, after reaching some threshold point, the current conduction will be takes place in the diode. So automatically what happens here, the LED will be connected in the as a load, consider as a load. So after some cases, the LED will operate. That means it is glowing. And in the case of second circuit diagram, it's a reverse bias condition. It is acts as an insulator, because even if you are giving increasing the voltage, external voltage supply by means of the battery, there won't be any current flow occurring in your diode. So there won't be any light illumination occurring in your LED. So this is the simple practical example for diode in a forward and as well as the reverse bias conditions. So here this the voltage current characteristics of a diode is given in this slide. So here what I told you, in a forward bias, after reaching some particular voltage level, that's a threshold voltage or reference voltage, the current conduction will be takes place. But in the case of reverse bias, even if we are increasing the voltage in a very higher level, there won't be any current flow. But after reaching some maximum voltage, maximum reverse voltage, the current conduction, the current flow the diode will be act as a complete conductor. The diode will lose the property, and the diode is considered as a dead diode, and the current flow will be occurring. So this is the VI characteristics of a diode. Simply, the diode in a forward bias, it will be act as a conductor, and in reverse bias, it will be act as a insulator. So these are all the some applications. So applications of diode is to protect the circuit from reverse voltage and to convert alternating current to direct current. Half wave rectifier, full bridge rectifier, it is being used. And also in our chargers, best example is our mobile phone charger that has an adapter, which is the adapter. What it does means the adapter input is AC, and the finally it will convert this AC into DC, and it is powering up our. It is being used to power up our mobile devices. And how to test the diode? By using the multimeter, if you connect the positive terminal to the anode and negative point to the cathode, means it will show some voltage value that I told you. No, in even the no biasing condition, there is a junction in the PN junction diode. The junction will have some potential. So if the multimeter shows the potential value, that means that the diode is in a working condition. And instead of this, if it is not showing any value, means so that is considered as a it is not working in a proper way. So from that we can come to the conclusion. So thanks for watching my video. In the next session, we will discuss the another topic in the analog electronic circuits. Thank you.